Good morning everyone. Welcome back to online class. Today we are going to do the numericals as well as homogeneous, the types of equilibrium constant solutions, that is homogeneous and the heterogeneous. So today we are going to start with the numericals. So it is from the textbook only. The following concentration were obtained from the formation of ammonia from nitrogen and hydrogen at an equilibrium at 500 Kelvin. Nitrogen, concentration of nitrogen is 1.5 into 10 raised to minus 2 molarity. Hydrogen, that is 3 into 10 raised to minus 2 molarity, and the concentration of ammonia is 1.2 into 10 raised to minus 2 molarity. Calculate equilibrium constant. So for this one, what is the given part over here? The concentration of nitrogen, hydrogen and ammonia is given over here. So first we will write the steps for doing the numericals is first we will write the equation, balance them, and then we will write the equilibrium constant, that is a product upon reactants. So here first we will write the equation, that is nitrogen N2 plus hydrogen H2 gives ammonia NH3. Kc equals to concentration of ammonia NH3 raised to the power 2. What is 2? 2 is from the mole of the ammonia, concentration of nitrogen and concentration of hydrogen, and the given in the question, now ammonia is 1.2 into 10 raised to minus 2 raised to the 2, nitrogen is 1.5 into 10 raised to minus 2, and hydrogen is 3 into 10 raised to minus 2 cube. So once we will solve that one using the calculator, we will get the answer 1.06 is equal to 3. How we will calculate? First of all, take out the 10 raised to power in a different way. That is here 10 raised to minus 4, and here 1.2 into 1.2 raised to the power 2, right? Divide by 1.5 different, and 3 3 is 2, 3 3 are 9, 9 27. So 27 into 1.5 is different, and the down one is 10 raised to minus 2, and 10 raised to 2 ka cube, that is 6. So here is minus 6 here, right? So minus 6 is this into, so plus will come. So minus 2 minus 6 is minus 8. Minus 8 will go out upper one, so it will be plus 8. So cancel this one. We will get 10 raised to minus 4 plus 8. So 10 raised to minus 4 and plus 8 is 10 raised to 4. Okay. So 10 raised to 4. So when we solve this one, 1.2 raised to 2 and divide by 1.5 into 27 into 10 raised to 4, we will get the answer. So always remember this, you will write in a standard form only. Okay. Now problem 7.2. At equilibrium, the concentration of nitrogen is given, oxygen is given, and NO is given here. Now what is the question asked here? That is 800 Kelvin. What is 800 Kelvin? Yes, the concentration of nitrogen, oxygen and NO is given, and in a sealed vessel at temperature is given 800 Kelvin. What will be the Kc for the reaction? The reaction is given, reaction N2 plus O2 gives 2NO. So first of all, the equilibrium constant, we will write the equation, and then we will write the concentration, that is Kc equals to concentration of nitrogen NO raised to the power 2, concentration of N2 and concentration of oxygen, and then substitute the value. It is quite easy only, same as problem 1. Okay. Now we are going to do with the homogeneous equilibrium. In homogeneous system, all the reactants and the product are in the same phase. What is the meaning of same phase? Same phase means of same gaseous state or solid state, not solid state, sorry, only gaseous state or liquid state. Why not gaseous state? Because solid, solid and solid will never react until it is in the ion form, right? So both should be supposed to be in a gaseous form or in the liquid form. So the example is given over here. Nitrogen plus hydrogen gives ammonia NH3, the balanced one. Second example is given similarly for the reaction CaCCOO C2H5 plus H2O gives CaCCOOH plus C2H5OH. Now, please can you try to understand what is COO functional group? You are studying 10th standard. That is OH is a alcohol group. COOH is a carboxylic group. Right? COO is a ester link. ESTER. Ester link. Right? So when CaCO and C2H5 is there. CaCO is minus, C2H5 is plus, right? So when water is there, HOH, so it will be H and OH, right? So H is H plus and OH is OH minus. So minus will go with the plus one, that is C2H5OH, okay? And CaCO is minus, it will go with the plus. Matlab CaCOH, there is a what? CaCOH is a acetic acid, C2H5OH is a ethanol. Okay, so this is a reversible. Aqueous means aqueous and liquid both are in the same phase only. That's why it is given over here. There is CaCO. Ethyl acetate, when reacts with water, gives acid and alcohol. That is CaCOH and C2H5OH. Basically, this is what homogeneous equilibrium. Why the symbol shows what equilibrium state. That is a reversible. That is a reversible equilibrium state. Okay. Next example is Fe plus 3 plus SCN. In the lab we have done the KCNS, right? Potassium cyanide, cyanide. This is what? Thiocyanide. What is that? Thiocyanide. Fe plus 3 plus SCN minus, in the reversible gives Fe SCN plus 2. Why plus 2 here? As you can see here, plus 3 minus 1 is plus 2. Right? So all the reactant in the product are in a homogeneous solution phase. Okay, now we will go with the equilibrium constant in a gaseous system. So far, we have expressed the equilibrium constant as a reaction in the term of molar concentration of a reactant and the product. So we use the symbol as a Kc for reactant involving gases. However, it is usually more convenient to express the equilibrium constant with PV equals to nRT. In the previous chapter, that is thermodynamics, we have studied PV equals to nRT with the three laws, that is the Charles law, Boyle's law, and the other Gay-Lussac's law. And we have gone with the ideal gas equation, that is PV equals to nRT. P is the pressure, V is the volume, N is the number of moles, R is some universal gas constant, and T is the temperature, right? So P equals to N by V, RT, yes. Pressure in a Pascal, number of moles, volume in a cubic meter cube, and T is the temperature in the Kelvin. Fine. Therefore, N by V is the concentration expressed in a mole by meter cube. So mole by meter cube is what? Concentration. Concentration is mole per liter, or you can say mole per dm cube. Oh, fine. So we will write, instead of P equals to N by V RT. So instead of N by V, we can write C, concentration. Fine. So we can also write P is a concentration of a gas, RT. What is R? We have studied the value. R is a 0.0831 bar liter per mole Kelvin. So at constant temperature, the pressure of the gas is directly proportional to the concentration. So for reaction in the equilibrium, H2 plus I2 gives 2HI. So basically, what we will write concentration, as we know concentration, how we will write concentration of the equilibrium state. Kc equals to concentration of HI raised to the power 2 upon concentration of hydrogen and iodine. Kc equals to what is the relation between here actually will come Kp. This is Kp. Kp equals to pressure we will write pressure Hi, the small one, down one, into the square. Fine. And pressure of hydrogen and pressure of iodine. Why we are writing pressure? Because we have to do the comparison between the Kp and the Kc. The relation between the Kp and Kc, we have to do it. Fine. So pH is what? Concentrate. P equals to CRT. So pressure of Hi equals to concentration of Hi, RT. Pi2 equals to concentration of I2, RT. P of pressure of hydrogen equals to concentration of hydrogen, RT. Understood? Now Kp. Now see here, Kp as it is written as Kc here. I told it is incorrect. This is Kp, right? The same. See here, it is down. It is written correctly. Kp equals to Phi square. And what is P? What is P? P equals to CRT. That is concentration RT. So what is written over here? what is done over here? Hi square RT square, and pH2 is what? Concentration RT, and I2 is what? Concentration of RT. So RT square and RT cancel. So what is left? This is called concentration. This is what? Kc. So we can write Kp equals to Kc. Yes. So both the equilibrium constants are equal. However, this is not always the case. So we are taking the second example of nitrogen and hydrogen. So N2 plus 3H2 equals to ammonia. Again, as we know, what is Kp? Pressure of ammonia square. How square and cube will come? Because of the number of moles. Because of the number of moles, right? So if it is a 2, then we will write square. If it is a 3, then we will write cube. And if it is other number 4, 5, then we will write that number. Okay. So basically, what is this one? P equals to concentration RT. So substitute the value and I put the RT square also. Here it is a cube. Then do RT cube also. Now value here. This is what? Ammonia NH3 square RT square, and here it is a 3 plus 1 is 4, means RT raised to the power minus 2 upon concentration of nitrogen and concentration of hydrogen, right? Nitrogen and hydrogen the cube is there. Okay, so then what happened here? See, so it is written over here like this, RT square and this one, then at last RT is raised to the power minus 2 and the remaining is completely, and this is actually what? This is actually a Kc. So Kc RT raised to the minus 2. Got it? Similarly, for the general equation, AA plus BD gives Cc plus DD. So Kp is what? Pressure. C is to power C, PD is to D, right? So pressure की जगह में we will write concentration. As we know, P equals to CRT, concentration RT. So we will write RT separately, C plus D, and RT separately, A plus D. So generally what happens? C plus D minus A minus A plus B. So this one will come above. Okay. So then what happens? That is, we can write as a RT delta N. Now what is RT delta N? Then we will write Kc RT delta N. Now what is Kp? Kp equals to Kc RT delta N. Okay. Now delta N is what? Number of moles of gaseous product minus number of moles of reactant, gaseous reactant. Okay. So Kp is equal to Kc is not possible in all the cases. So we will write generally as what? Kp equals to Kc. This is the general formula. What was that? That is Kp, that is equals to Kc RT delta N. Okay. So Kp pressure should be expressed in a bar. 1 Pascal, that is equals to Pascal over 1 Newton square per meter square, and 1 bar equals to 10 raised to 5 Pascal. So problem we will do, that is 7.3. PCl5, PCl3 and Cl2 are at equilibrium at 500 Kelvin and having a concentration 1.59 molarity. PCl3 1.59 molarity is PCl3 and 1.59 molarity is Cl2 and 1.41 molarity is PCl5. So let's calculate the Kc. You know what is Kc? Kc is the equilibrium constant, right? So for finding Kc, what we will write? Product upon reactant. We will write product upon reactant. That is concentration of a product upon reactant. So if it is in the plus, we will write here in the always in the multiple format only. So the value of PCl5, PCl3 is 1.59. Value of C chlorine is 1.59. That's why 1.59 into 1.59 square is there, and 1.4 divided by 1.41, you will get the answer 1.7. Okay. So till here we are doing. Next lecture we will continue from here. Thank you. Hope you understood the topic very well.